Let's talk about Claude Code. In the next few minutes, I'll cover what actually matters, the trade-offs, the gotchas, and the stuff most tutorials don't tell you. Let's get into it. Here's what Claude Code is actually doing when you run it. It's not reading just the files you touched. It's walking your project tree and stuffing as much of it as possible into the context window before it even looks at your prompt. Every invocation. That context window is a fixed budget. Claude 3.5 Sonnet sits around 200K tokens, and once it's full, older context gets dropped or the model starts degrading coherence silently. No warning, no error, just worse answers. The mistake engineers make is treating context like RAM with swap. It isn't. When you ignore .claudeignore and leave in your node module's lock files, your dist folder, your auto-generated protobuf stubs, you're burning that budget on noise. The model doesn't know those files are irrelevant. It weighs them. So by the time it gets to your actual logic, it's working with a fractured picture. Fix this now. Audit what's in your tree, write a .claudeignore that mirrors your .getignore plus generated artifacts, and treat every kilobyte of context like it costs you reasoning quality, because it does. Claude Code is not a streaming text editor with tool access bolted on. It's an agentic loop, and understanding that loop is what separates engineers who use it well from engineers who burn tokens and blame the model. Every action Claude Code takes, reading a file, running grep, writing a patch, executing a test, is a discrete tool call. Each call is a round trip. Tokens in, tokens out, latency paid, context window consumed. The model doesn't see your code base. It builds a picture of it incrementally, one tool call at a time. So when you hand it a vague task like refactor the auth module, you're not giving it a job. You're giving it a reason to issue 20 tool calls, accumulate 12,000 tokens of intermediate state, and potentially hallucinate file structure halfway through because the context got noisy. Task decomposition isn't a productivity tip here. It's a cost and reliability control. Tighter task boundaries mean fewer tool calls, smaller context windows, and a model that's reasoning about one thing instead of reconstructing your entire repo from grep output. Debug at that level, and your results change dramatically. Most engineers drop a Claude.md in their repo root and treat it like documentation, a README for the AI. That mental model is wrong, and it costs you. Claude.md isn't read as context. It's prepended directly into the system prompt, before any user turn, before any tool call. That means it operates at the highest privilege layer in the entire conversation architecture. Instructions there constrain Claude's behavior the same way a system prompt does in the raw API. If you're writing it like prose documentation, passive, descriptive, informational, you're leaving real leverage on the table. Write it imperatively. Enforce tool usage policies, output formats, forbidden patterns, review checklists. This is your root level configuration surface. Treat it like one. Here's what nobody tells you about long Claude Code sessions. They don't just get slower, they get dumber. Every tool call result, every file read, every grep output, every compile error gets appended to the context window. And the model isn't reading it like a database. It's attending over all of it simultaneously with attention that distributes across every token. The longer the session, the more noise competes with signal. Engineers assume the model is tracking a clean mental model of the task. It's not. It's drowning in its own working memory. The fix isn't prompting harder. It's scoping tasks to complete within a single session, then starting fresh. Treat sessions like stack frames, not terminals you leave open for days. Most engineers using Claude Code are running it like a single-threaded process. That's the wrong mental model. Claude Code supports spawning parallel subagent instances, separate Claude invocations that execute concurrently on independent subtasks. If you're doing a multi-file refactor, generating tests across a large codebase, or running analysis on isolated modules, and you're doing that serially, you're leaving 3 to 5 times the throughput on the table. The mechanism is straightforward. Claude Code can decompose a task and delegate subtasks to child agents with their own tool access, context windows, and execution environments. These aren't threads, they're full agent instances. The coordination happens at the orchestration layer, not inside a single context. The mistake engineers make is assuming Claude Code is inherently sequential because it feels like a chat interface. It's not. It's an agent runtime. Treat it like one. Structure your prompts to identify parallelizable work, let the orchestrator fan out, and collect results. That's the shift. That's the core of it. If you want more content like this, practical, no-nonsense technical breakdowns, follow Hired by Basics. See you in the next one.